Hi everyone. Today I'm going to solve this specific HackerRank problem. But before solving this problem, I'll touch the basic theory which are needed to solve this problem. Firstly, we will go through the problem and try to understand what they expect, and we'll get some ideas about how big O works for some of the data structures. Okay, I'll go through this one first. Give a pointer to the head of a linked list. Insert a new node before the head. The next value in the new node should point to head, and the data value should be replaced with a given value. This is simply, it says, we can understand inserting a new node to the head for a single linked list. And basically, when we before we give a solution, we should have understand about the input and output. In addition to that, the constraints. When we check the constraints, it's clear that the n should be less than 1000, like the list element also should be, number of element also should be less than 1000. So now we will check the input. When we check the input, clearly they have explained initially the list in null. After inserting 383, the 383 is the new head. The null is going to be assigned to tail. So for each and every new element, you can understand it goes to the head position. So all other elements are moving to the next element. This is how it works. When apart from that, what they are trying to do is every time they are trying to explain us insert a new node at the head position. This is where we have to get to understand. Okay, you can go through in detail, and if you don't understand the given scenario, you can reread and try to understand what they expect before solving a problem. Anyway, before solving a problem, first we should have proper understanding what we are going to solve. Okay, this is crystal clear. They are expecting their expectation, and so we'll check their implementations where we need to start our code. When we check the code, okay, I'll refresh this page. Yes, when we check the code, we can understand their implementation as well. They have created a class which produces a singly linked list node that has the data element as well as the next element. Then there is another class which is called linked list. This is where the implementation is going. So in here, um, we can understand they have initialized the head node and they have initialized the tail node as well. This is a very important point. If we don't mark the tail, then you should have proper understanding how the big O notation works. We can look a little bit later how the proper singly linked list works, and what is the big O complexity behind the every action, such as delete, insert, search, those steps. So before we are solving problem. Yes, we'll minimize this one here. They are trying to apply the solution over here, right over here. So just if you go through this one, it's clearly understandable how this works, and I'll explain why there is no any direct connection here. And that means you might have some questions why the singling uh, is not connected. That means not inherited. The thing not inherited with this class. It's simply working like an independent class. Why like that kind of questions might be arise in your hand. We will check that one step by steps. Okay, before I solve this problem, I'll go through the basic data structures about array, linked list, and list in Python, how it works. And I'll give a brief ideas before we touch over here. Okay, let me go over there. So this is the Python, this is the URL I used to solve the problem. So you can just copy and you can try out when it's needed. So before we touch any data structures, or before we decide any data structures to solve a problem, we should have a proper idea which data structure is suitable for best solution. But in this specific question, it's crystal clear they have given the data structures. But in real world scenario, or when you work in a real project, they don't simply say you should use array or you should use list. They don't mention anything. It depends on the given use case and the scenario, the problems. It may differ. So there are some questions in HackerRank also. They don't say specifically which data structures should be used in order to solve this problem. So in that scenario, you should have a proper understanding about data structures and big or complexity. So that's why I'm going to touch over here. I'll simply go over here and show how, just I'll remind you how it works and all. Yes, here I have taken 3 data structures as earlier mentioned: list, array, linked list. So when we insert into head, that means, let's say there are some certain there are scenarios. Sometimes the list might have existing elements, more than one, or single element, or it could be empty. Likewise, for all these 3 categories might have the same scenario. So what we can do is we'll assume that the list is not empty. In this particular scenario, if the list is not empty, then what will happen? Then let's assume that we have okay, I'll take some example over here. Let's assume that we have some elements, number 2, number 3, number 4, right, in a list, or it could be in an array, no problem. Both are most probably very same in this specific scenario what I'm trying to explain. When a new node is coming, when a new element is coming, and assume that there's a new element is coming here, number 5. So number 5 is going to be inserted over here. So what we have to do when we insert here, all other elements should be swept it should go here, and it should go here, and it should come to the next position. So it should be swept. So if there are n element, there are some actions should be carried out. That means we are going to swap the elements. The array also same. So that's why it says big complexity is n. But for the linked list, it's totally different. I'll explain that. When it comes to linked list, here we have element 1, we have element 2. This is the next position. Here also we have next position, but it could be null. If there is another element, yes, the next element should be pointed to the next element. Let's say if it's an element here, E3, yes, the next position is pointed over here. Right? But here it's null because there are no any more elements. So it's pointed here. So when we insert a new element, let's assume that E0, then what will happen? We need to create a node. The node means it should have data plus the pointer. Pointer means it could be next pointer. Here we are talking next. So simply what we have to do is a simple action. We have to insert here, and this should come here. The data element coming. The next element should point to the E1. That's how it works. So it's very direct scenario that could be assigned. That means the existing head data should be assigned with the new elements next pointer. That's how it works. So that's why it says simply n. Insert an element at the last point. Inserting at the last point. When it comes to the list, yes, it's a simple thing. We can insert. I'll show you how it works. But when it comes to the array also, it's same. However, in linked list, it's a little bit different. If the tail is already marked, then it's 0n. Just we can change the tail. If it's not happened, which means the tail was not tracked, then we should loop all the elements to find out the tail. That's why 0n. Next is search. When it comes to search, if we know there are two types of search we can do in the list. Let's say if we know the index, we can directly give the index and find out the element. If we don't know, just assume that if there is no ideas about the index, then we need to check by the value. Then we should do a looping. Then it should go to the 0n, or if we use any other data structure algorithm such as binary search, then it should go 0 log n. So you should have ideas which is better, 0n or 0 log n. If you don't know, just comment it. I'll have another separate session about that, about the big complexity, how it works, which complexity is better than others, likewise. Right, next one is deleting an arbitrary element. Yes. When it comes to deleting arbitrary elements, linked list also, we should do looping. I'll have a separate session for that to check how it works practically. For right now, we'll assume that this is how it works. When we do the implementation, we can understand more. Yes, deleting arbitrary the other data structures such as list and array, both are same because we need to loop the elements. Deleting head. Yes, when we delete the head linked list, we all as we know already the head is tracked. We just change the current head to the next element. If I elaborate more, let's assume that E0 is the existing head element, and just we have to drop that element and change the new head as a E1. So it's just a direct scenario, no need to do any looping. That's why it goes 0, 0, 1. Deleting tail. As earlier I mentioned, when it comes to the linked list, if the tail is already tracked in the singly linked list, it's direct scenario that we can remove. Otherwise, we have to travel. We have to do looping, and the complexity would be 0n. But deleting tail for list and array is a direct scenario. We can use the pop or any other suitable one. So this is how it works. Now we'll go to the coding level, how we can insert in a list. And then you might get some better ideas. The list, let's say if I want to insert at the head, insert and 0 is the position that I have to put. This is the element data, then that's how it's works. Then list at a tail, you can use append. Then it should go as default. It goes to the last position of the list. When it comes to search, you can see here the given list, and I want to find out the number 3. What I have to do, this is the element to search. I can use if int, then I can find out is available or not. Right? It might return. Right. Next one is search by index. If I know the index of the run, what I have to do is simply I can do this kind of operations. Right? Delete. When it comes to delete from a list, we can delete by element. That means you just I can give the element value here and remove. If you use index, what we can do, I can use the pop. Then it will be removed based on the given index. If I want to delete the last element, just use pop without giving the index number. When it comes to array, it's also very close to the list how it works and all, but there are some different scenarios and different use cases. We can get maximum utilization using array than list. If you have any questions or if you need any more lessons about that, just comment over here, then I can provide another lessons in detail comparing array and list, how in which situation you have to use list, in which situation you have to use array, and are there any data type constraints, or are there any constraints like that we can discuss in detail. But here what I can do is when we create array, this is how we create array in Python. When insert, yes, you can insert this element. So I'll go through very quickly. When you use NumPy, it's also like I have given this in scenario. Yes, now I'll show you how to implement a linked list, because this is an important part. I'm going to show you in the real world a simple scenario example how we can implement a linked list practically, so you can get more ideas before we touch the solution for the given scenario. Okay, I take my Python ID. Yeah, I have taken my ID. So I'll first we'll create a class which can produce a not class not that means we'll pass data to create the node. And we do the visualization. That means self dot data equal this data. Self dot max equal first. None. This is the initialization. When you create a node, it should have the data element and the next pointer. The next pointer initially will not present none. This is the node we have created. Next, we will implement the linked list. There is no any direct connection between linked list and node, or we are not going to use any features. So it's not necessary to use our inheritance. We'll mark this one as the creating node. So we can mark this one as the implementing this. Okay. Let's do initialization first. When we write the initialization code, we should have understand what are we going to do here. Let's say initially my head should be null, right? So I can do like this. Self dot sorry dot head. I am going to assign like null. This is the one I'm going to assign. Initially my head should be null, so I'll create like that. Then what I can do is I'll insert element at the head. This is the one I'm going to initialize. Implement, sorry. So I write a new method, insert into head. We need to pass element. So when I pass the element, initially create the node that should have the data pointer and this one. So we'll create the node. New node. We'll pass the element. Okay. Okay, here we have some intent case. We will adjust it that case. Okay. Then measures why it says. Let me give a few seconds. I'll check it quickly. Yes, the indentation is corrected. Now, what I can do is we are trying to create a new node using the node class. Then what I can do is, if the head is not initialized, or if the head is initialized as none, then let's say I don't want to keep uh, null or any empty fields as a head. So what I can do is I can check if the head is none, or likewise we can check it. But in this scenario, I have already decided to keep null as the head. What I can do is no need to check any that kind of um, extra checking. So what I'll do is I'll just create the new node, and I will continue to assign the new node as a head. Now I can get the current node like this. Current head is search dot head, and then yeah, sorry, you can find out another mistakes. Another mistake I have done here, the indentation. It should go here. It's simply you can do is you can use your tab key to adjust it, or what you can do is here also you can remove this scenario. There are some, as I know, you can go here and check it, like reformat the code. Likewise, we can adjust. There are several ways that you can find out how to adjust the indentation. As I have switched from JavaScript, uh, sometimes I miss to follow the indentation properly here. So you also might face the same problem if you are coming from the other languages. That means switching from other language to Python. So, but the theory all are same even if it's from different language. Okay, now what we can do is the current head is assigned here. Now what I can do is I have already created the new node, and current node also retrieved. Now the new node should be assigned as a new head. So self dot and equal new node dot data, and the new node dot next should go to the current. That means existing. We mark it, this is like existing head. Right, now we have assigned those nodes here. We'll simply say yes after everything is done. We'll simply return the head. Then we can say simply self.head, we can return it in case if you need anything. Okay, next we'll print the def display. List. Yes, when it comes to displaying the element, what we have to do is we have to just reverse. That means we have to loop the list. For example, let's say first we'll get the current head, because you can understand here I haven't marked or I haven't tracked the current tail. It's a different scenario in order to improve the data structures and algorithm. Here what I'm going to try to focus is here, and is how to display the already stored item. Yes, first we'll get the head. Self.head. Yes, from the head, what we can do is we'll use a while loop. Here I'm not going to validate use whether the list is none or empty, because as I have already initiated, the null is already there in my list. So I'm not going to do that validation. In your case, if null is not in your head, then you can initialize the head is none, and if you don't want none, you can put the condition to remove the none to make sure your structure has the real element. Yes, now I have assigned the current head. Now I'm going to do is I'm going to use while loop in order to get the all element from head. If I want to elaborate more, what I can say is this is the first element I'm going to traverse. First I'll get this element out and assign to the element. Then I'll use the next pointer to get the next element. Likewise, I'm going to traverse through the structures. Okay, right, next we'll assign elements. Initially, it's nothing. Right, then I'll do while loop until the current element there. I'll show you how to do that. Until the current head is true, we will do our loop. Do that elements here, and we will assign it here. We'll assign it like this. As I'm going to keep everything in the integer, so I'm not going to take any validations or anything extra. What I can do is here is take the first current head, and I'll assign the current head dot data, first element, now now after fetching the first element, what I can do is I'll pass my pointer to next element. Now current head should go to current head dot next. So this loop will work until it gets false. But in order to print, what I do is I'll do a small condition over here. If current head, sorry, current next current head dot next. Is true. That means I need to have the next element, then only I have to print like an arrow marks. Like this mark. Then I can print the elements. I hope you can understand this is not the complex scenario. If next element is there only, I have to print it. Right, next, yes, we'll do simple object creation. Equal the class name. This is creating the object. Then we'll add to has. Run this code. Attribute object has line number 32. Dispelling this element, integer object has no attribute data. Okay, I found the scenario. Yes, actually the issue was I made a mistake when I assigned to the head. That means this is the existing, and before we just create a new node, then we get the existing node before we assign the new node as the head node. This is the place where I have done some mistake. New node, okay, creation is correct. Then the existing node also correct. I have found it, this is the existing node. But when I assign the self-root head as a new element, I have assigned the data. That's why it says integer has no object attribute data. So this is the node should have data and next pointer, as I have already mentioned here. The element here, the element in the data. This is the node. The next, these two attributes should be there. So this is where I made mistakes. So I made the mistakes and I correct the spelling mistake also. So now I hope that it should work. Okay, let me run and see. Okay, I'll remove this one. Delete. Let me check. Now, what's the issue? Unsupported type string. Yes, supported operand word plus null type and string. Yes, we'll go to that place quickly. This is you can understand how I debug when I do mistakes. Yes, you can see when I run this code, I got the issue here, unsupported, because mistakenly I have made this one as a none. So here I am trying to do the string. So what I'm going to do is I'll fix it this one. I'll put it like this, the initialization. Right now, let me check. Yes, the null is already in the head. Then whenever I put it, the 10, then 20. Then I put the first element as a 10, then 10 is the first element. If let's say if I have only the 10, then 10 should go in head. Then when I enter the 20, 20 goes to the head. So this is where now I understand. I'll brief up. Here just I have created node element that has two attributes. That means data and next pointer. Initially the next pointer I have initialized as none, and that's the functionality only this class does. Secondly, the single linked list implementation, when I initialize the single linked list, or when I initiate the linked list class, or automatically the head element, self-load head, create a node which is null. The element is null. If you don't want, yes, you can simply remove this one and assign something none or something. You can do some extra validation, but in my case, null I have assigned. So then when it comes to the insert into head, I create a new element and retrieving the existing head, then using the new node I am assigned to as head. Then the next pointer is to be pointed to the already retrieved head. Okay, then when we come next, sorry, display the linked list, what we can doing is here we are just looping the elements from the head node, changing the using the head node, we are retrieving one by one. That's how it goes. You can understand how I have used the next pointer to loop every element. So this is how it works. Now we will shift to our main solution. Yes, this is where we have to check our code. But here you can identify their implementation which is given. They have created the node, but when it comes to the sibling list, the head they have initially assigned as a none. So you will get better understanding. There should be some validation that we do. Initially, you will get our new node. The new node should be created by the given data element. So what I'll do is I'll create using the sibling list class to create the data. Now data is created. If the list is yes, we had, as I said, we should have some validation. We'll check if it is not none. We'll simply assign the new node as the new node dot next should assign to the given node, which is the currently the head element. If it's not none, simply you can return the new node. So this is how the solution will come. Let me check, we'll run the code and see. No, something wrong. Okay, let me figure out what's happening here. Yeah, sorry, I made a mistake over here. The validation should come like this. If the list is not none, then only, I mean, there are some existing elements which are occupied in the head node. So we should validate those condition over here. So earlier I made a mistake, so I have corrected. Now let me check. Yes, it works fine. Test cases. Okay, let me submit the code and see. Yes, all are correct. So I hope you understood this well. And the implementation already I have explained here. If you have any questions, yeah, please share with me.